This video is on the formative review packet to help prepare for the Unit 2 Topic 1 test in Algebra. So number 1, 2, 3, and 4, you are evaluating the function at each given value. So for number 1, we're given f of x equals 1/3 times 6 to the power of x. Remember, this is also like writing 6 to the power of x divided by 3, because multiplying by a fraction is really dividing by its reciprocal. We know that x is 2, so this is really 6 to the power of 2 divided by 3. 6 squared is 6 times 6, which is 36, divided by 3, and that equals 12. So f of 2 equals 12. You didn't actually have to write this part right here, but I'm writing it just to put the whole idea of function notation into your mind. Problem number 2 says f of n equals 10 times 2 to the power of n when n equals 5. So f of 5 equals 10 times 2 to the 5th. Well, remember that 2 times 2 times 2 times 2 times 2 is 2 to the 5th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So notice we have 2, 3, 4, 5 2's. So this is going to be 10 times 36, which is 360. So f of 5 equals 360. Next, number 3, we have f of negative 2 equals 10 times 2 to the power of negative 2. This is the same question, but now our exponent is a negative. Remember that the exponent only goes for what's directly in front of it, so it's only going to relate to the 2 and not to the 10. So this is going to be like 10 times 1 over 2 squared, which is 10 times 1/4, because 2 squared is 4. So this gives us 10/4, which can be simplified by dividing both the numerator and denominator by 2 into 5/2. So f of negative 2 equals 5/2. Finally, for number 4, we have f of x equals 3x plus 10. So now they're writing it in function notation, and they're not telling you what x is. But they really do, because what's inside the parentheses represents x. So f of negative 3 is going to be 3 times negative 3 plus 10. 3 times negative 3 is negative 9, and negative 9 plus 10 is 1. So f of negative 3 equals 1. For question number 5, you're being asked to sketch the graph of the following function. And over here they give you a hint. We haven't really talked about graphing that much this year so far, but you have learned it in previous classes. So we're just going to make a little t-chart. We're going to have our values of x and our values of f of x. And they gave you domain values to pick. They gave you negative 2, negative 1, 0, 1, and 2. So 4 times 2 to the negative 2nd is the same thing as 4 times 1 over 2 squared, which is 4, and 4 times 1/4 is 1. 4 times 2 to the negative 1st is 4 times 1 over 2 to the 1st, which is 2, and 4 divided by 2 is 2. 4 times 2 to the 0th is 4 times anything to the power of 0, except for 0 is 1, so 4 times 1, which is 4. 4 times 2 to the 1st is 4 times 2, which is 8, and 4 times 2 squared is 4 times 4, which is 16. So each of these becomes ordered pairs. We've got negative 2, 1, negative 1, 2, 0, 4, 1, 8, and 2, 16. So I'm going to plot these points on my graph. So I've got -2, 1. I've got -1, 2. I have 0, 4. I have 1, 8. And I have 2, 16. So we kind of see what this graph looks like. Now let's talk about what we know. We know that our variable is an exponent. So this graph is going to be an exponential graph because it is the graph of an exponential function. If you remember, we've talked about exponential functions always approaching a number but never actually hitting it. That number usually being 0. I can fold a paper in half, and then in half again, and then in half again. And I can keep folding it in half, and it's going to get infinitely small, but I can never make paper disappear. So this graph is going to approach 0, but never actually hit it. All right, it's just going to kind of run along the x equals 0 line, but if we got closer in, if we kept zooming in, you'll see that it's always going to be a little bit above 0. So this is our f of x graph, and we know that it is exponential. The next question is, what is the y-intercept of your graph? Well, the y-intercept is when your graph crosses the y-axis. So our y-intercept is right here. It is when y equals 4. It's better to put it in terms of y, but it also is the ordered pair 0, 4. This would be your better answer, though. Finally, is the function increasing or decreasing? Well, we read a graph left to right, so I'm going to read it like this, and I can see that my values are getting larger. So my graph is going to be increasing. My function is increasing. I also should point out that even though we picked certain values of x, I can plug in any value of x into this function. It's an equation, and so that's what tells me that this graph is going to be continuous, meaning I'm going to connect all the points, because there's nothing on here that says you could only have integers or whole numbers or a specific set of numbers that would cause the graph to be discrete. The graph is continuous, so we connect the points. We never have to lift our pencil in order to draw this graph. For question number 6, we're going to graph the following function. Now this function is given to us as a table, and one thing we know about tables is whatever comes first is the x. So in a table where it goes in rows, the first row is the x, the second row is the y. If the table was written as a columned table, the first column would be x, the second column would be y. It wants us to label each axis and create a scale with equal increments. Well, we can see our smallest x value is going to be 1, and our largest x value is going to be 14. For y's, our smallest x value is going to be 61, and our largest x value is going to be 88. So we want to make sure that our increments and our labels cover these points. If you count, you'll see that there are 15 boxes, so the x should be pretty easy. We have to go by ones. We also know that the label is months because we see that in the table, and also the size of whatever it is dependent on the month. Usually time, like months, is not dependent on anything else. So now we have to figure out y's. If we went by 5s and we have 15 blocks, 15 times 5 is 75, but that clearly won't cover us up to 88. So we could do one of two things. We could make a break in the graph and then go by smaller increments, or we can go by tens, for instance. I don't recommend going by weird numbers like 6 or 7 because your counting gets off and it's hard to predict where the point is. So we can go by tens. For spacing issues, I'm going to skip every other one. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. So now I need to plot the points. Well, at month 11, we have 84. So we have 80, it's somewhere around there, 84. At month 3, we have 68, which is high up, close to 70. 14, we have 88, which is high up, close to 90. At month 10, we have 83, which is lower, close to 80. At 1, we have 61, which is close to 60. And at 6, we have 72, which is close to 70. Now, do we connect the points? We do not connect the points because we're not given enough information to assume that this is continuous. We are just given a table of values, so we have to assume it's discrete, and we do not connect the points. The last thing we need to do is label the y-axis, which we're going to label size in centimeters. Always be as specific as possible and include the units if you can. For question 7, we're going to use the following parts for A through E. We're going to use the following graph for parts A through E. So explain why this graph shows a function. If I took a vertical line and just went along, my vertical line would only touch my graph at one place for every value of x. So this is a function because for every value of x, there is only one y value associated with it. So that is the definition of a function. For every x, there's only one y. So it next asks us for g of negative 3. Well, negative 3, we're going to find is right about here. So g of negative 3 is 16. Next we have g of 1, and g of 1 is right here, so g of 1 is 1. G of 0, that's when x is 0, is right here at 2, and this is called the y-intercept. Finally, they give us g of x equals 4. So they're asking, what is x when y is 4? Well, here's when y is 4. So we're looking at that point right there. X is negative 1. For question number 8, we're using the 3 graphs below to answer the following questions. So we have the graph of f of x, we have the graph of g of x, and we have the graph of h of x. The first question is which function or functions is decreasing on the interval x is greater than 3? Well, here is x is greater than 3, so it is decreasing, but notice that it does start to increase again, so it's not decreasing on this whole interval. If we want, we can say f of x until x equals 9, or you can say not f of x at all. Here's x is greater than 3. Well, here is x is 3, but x is greater than 3. It is decreasing, so g of x. And then finally, here is h of x when x is greater than 3, and that is clearly increasing, so it won't be h of x. Next question, what is the y-intercept for each function? Remember that the y-intercept is where it crosses the y-axis. So everywhere I see the graph crossing the y-axis is where the y-intercept is. Notice with this question we have two parts crossing the y-axis, but one is a closed circle and one is an open circle. The closed circle means it is a point at x equals 0, so that's the one we want. So for f of 0, the y-intercept is 0. G of 0, the y-intercept is -4. And then h of 0, the y-intercept is 0. Next I have the question f of 3 plus g of 3 plus h of 3. So we need to find what f of 3 is. That is right there. Sorry, hard to see with my pen, but it's at 6. So f of 3 is 6. G of 3 is right there, which is 5. And h of 3 is right there, which is 1, 2, 3. It's 3. So 6 plus 5 plus 13 gives us 14. So f of 3 plus g of 3 plus h of 3 is 14. Next question says f of a equals 6. So what does a equal? So in this question, they're asking us what is x when y is 6. So if we look at this, and it's going to be hard for me to draw with my pen, but there is when f of a equals 6. So we have a point here and a point here. So a is going to be -9 or 3 when f of a equals 6. Next question is h of -1. So when x is -1, what is h? Well, what is h of -1? Remember, the closed circle means it's a solution, the open circle means it is not. So this is going to be -1. Next question, what are the x-intercepts for the function f of x? So the x-intercepts are where my graph crosses the x-axis. So that's going to be here, here, and here. I know they're not the most exact. It looks like it goes off a little bit, and it does if you know what the function is, but for all intents and purposes, we're going to say -6, 0, and 6 are the x-intercepts. So when x equals -6, when x equals 0, and when x equals 6, we have the x-intercepts for the function of f of x. Finally, there's a bonus question. This will not be on the test, but it does impress certain teachers. I want you to write the type of function next to each graph. So, this first function is one that you will not study until pre-calculus, but it is a sine function. This is a trigonometric function. G of x is a function we're going to study next semester. It's a parabola, and it's a quadratic function. And finally, h of x, you may have heard me say this name in class. You won't really study much of this right now formally, but it is a step function. If you want to be even more precise, looking at this, it tells us it is actually a greatest integer function. That's its more precise name, but the greatest integer function is a type of step function. For question number 9, we're asked to determine if the following mappings are functions. Well, remember, the definition of a function is for every x, there's only one y. So each of my x values should only have one y value associated with it. So this first one is a function. So each x has only one y value associated with it. This one's also a function. It doesn't matter if they all go to the same number. It just matters that the x only has one output value associated with it. So for instance, with this one, we have 8 has 1, 11 is 1, 4 is 1, but 7, negative 7. If I input negative 7, I'm going to get an output of either 5 or 4. So this is not a function. When the input is negative 7, there are two outputs, which are 5 and 4. For question 10, they ask you to make up a table that is a function. So your answer is obviously going to be varying and different from mine. But basically, I just want to make sure that I only write one x for each box and my x doesn't repeat. So I might say 0, 1, 2, 3, 4. And my y's could be 1, 2, 3, 4, 5. For every x, there's only one y. But for number 11, we're supposed to make up a mapping that is not a function. So maybe my input is 1, 2, and 3, my domain. And maybe my output is 4, 5, and 6. So if 1 went to 4 and 2 went to 4, that would be fine. But if 2 then went also to 5, we don't have a function anymore. Maybe 3 goes to 6, and maybe 3 also goes to 5. So that's not going to be a function either. When your input has more than one output, then it's not a function. Finally, for question number 12, please explain why the following situations would or would not be a function. The number of lottery tickets purchased by each individual at a gas station, and the amount of each individual wins from the purchase of lottery tickets. So we're looking and seeing if I buy 5 lottery tickets, could I win $10? Could I win $20? Could I win $1 million? The problem is that if I buy 5 tickets, there's more than one possible output for that. If I buy 1 ticket, I could win nothing. I could win $1 million. There's many possible outputs for one input. So this is not a function because the individual could purchase 2 lottery tickets, for instance, and win nothing or something. Could win money, might not. So there are many possible outlets. Sorry for my handwriting. Many possible outlets, sorry, I definitely didn't mean that. I meant outputs. Many possible outputs for one input, which is not a function. Now, the number of toppings ordered on a pizza from Papa John's and the total cost of the pizza. Well, we know that the more toppings you put on, the higher the cost. But I can't put 5 toppings on my pizza and have it cost $10 and also cost $20. That's not possible. So this is a function. And this is because the number of toppings on a pizza can only have one cost associated with it. Every time you add a topping, the price will increase. So this is a function. And that is the end of our review packet.